So welcome to Robotics 1 class. And now I'm going to share my screen and so that I can discuss the Canvas shell that the online students can also see. So again, my name is Sangram Redkar. This course is EGR 545 Robotics 1. And here is the course overview. My email sredkar@asu.edu. My phone. Typically, I'm in my office all the time. So please just send me an email and stop by. My office is in the Technology Center 101A. In this class, we are going to talk about analysis and design of robotic systems. We will be focusing on kinematics. We will be focusing on dynamics. We will look at coordinate transformations, system modeling, and some hands-on activity. This is the textbook, Introduction to Robot Analysis, Control Applications by Saeed Niku. You don't really have to buy it. Even if you get an older version of the textbook, that is totally okay. But I promise you the material that we will discuss in class and the supplementary notes which are online should be sufficient to gain the understanding of important robotics concept. So what we are trying to understand, we want to learn about kinematics and dynamics of robots. We also need to understand how to use software tools to design the robots and how to become successful. Please try to attend all face-to-face classroom sessions. Then look at all the assignments, do the pre-class activities. And what I mean by that really is I would encourage you to explore the Canvas shell. All the lectures are uploaded. So you are welcome to review the lectures and you are welcome to try to attempt the assignments that are already posted. Then again, A is 90 and above, B, C, D, E. Assignments are 60%. Project is 40%. Yeah. Do you need plus and minus grading? No, I don't. So all the assignments are to be uploaded on Canvas. No paper submission. And please be careful about add and drop deadlines. And here is the class schedule. So the first class is going to be introduction. This 1 week, this class and next class, I will try to talk about the basic kinematics, Newton's laws, what is vectors, scalars, how they are used in robotics, etc., etc. Then we will talk about kinematics. Then we will go on to forward kinematics, inverse kinematics. We will look at the velocity, which is called as the differential motion. Then we will talk about the dynamics. I just want to caution you at this point. I have noticed that up to this differential motions, things look super simple. But as soon as we apply those principles to solve dynamics problems, some of you may feel all of a sudden this course is overwhelming. So be very, very careful. Even some of the material that we discuss is very simple. Please pay attention. Don't skip the homeworks or just don't copy the homeworks. Try to do them on your own. We will do the static force analysis, Jacobian and everything. Continue on to the dynamics, Lagrangian dynamics. And then we are going to use how to use Matlab to generate the equations of motion automatically, solve the equations of motion. And then we will look at applications, trajectory planning, And then finally, we will look at the control systems theory, how to control. Then we'll talk about the root locus state space. Then we will look at PID control, nonlinear control. And then typically the last week is for review or to catch up on the material that I did not cover properly, or I may have just skipped through some part of the material. Next part I want you to be aware of is the assignments. These assignments are already posted. And not only that, the help to the assignment is already uploaded. So if you think you're a self-learner, yeah.
So if we do an assignment early, let's say we get like a 70 or something, could we redo that assignment and resubmit it before the due date occurs?
Yeah,
Sure.
yeah. But most of these assignments are going to be very straightforward. So I don't anticipate anyone having any issues with assignments. As an example, and these assignments are designed not only to give you some important concepts of robotics, but to equip you with general skills for your professional career, improve your profile. So for an example, I don't know if anyone has looked at the assignment number 1. Assignment number 1 is super simple. Download and install Matlab. And instructions are over here. Create a MathWorks account. And then I want you to complete these 4 courses. I know some of you may say that this is boring, but then you can actually skip through it and then finally just take the quiz and you should be good. And you can take that quiz as many times as you want. But the most important part is at the end of this course, you would get a certificate from MathWorks. Download that certificate for 2 reasons. One, you have to upload it as a deliverable. So I would like to see course certificates on your name from Matlab saying that you successfully completed these 4 courses. And I would strongly recommend that link these certificates to your LinkedIn profile, because in the past, my students have gotten jobs based on the LinkedIn. So if you actually do these, it gives you a certificate that would actually make your LinkedIn profile stand up. So just please follow this and start working on this. There is no robotics here. So you can start now and try to finish this by the deadline. Any questions? Again, this is not a group assignment. You will get individual certificate that needs to be uploaded. Any questions? Yeah. No, 4. There are 8 courses. So don't worry. There are other courses, but I will give you other courses after I finish the relevant content. So 4. So then assignment 2 is on the kinematics. Again, this assignment is already uploaded. Partial solution to this assignment is also uploaded. Hint? Yeah, so I'll show you. So basically what you need to do is, if you want the written hint, that is here. If you want me explaining the problem, explaining the hint, because students say, even though I give them the nice write-up, they say, oh, can you explain it? That hint is also there. Actually, as a matter of fact, one time I got so carried away that I gave the entire solution. I think that is also there. So assignment number 3 is again, yeah, and you will see that sometimes I do that. Assignment. So there is one more assignment that I want to tell you. You don't have to wait for me to assign you this assignment. For this assignment number 7, here there is SimScape on RAM, state flow on RAM, control design on RAM, and image processing. So before we get to the last part of this course, I would ask you to finish these 4 courses and get the certificates and upload those onto Canvas. And so, I mean, think about it. Assignment number 1, you should not have any problem is scoring 100%, because like infinite attempts, right? You can get A at the end. So it's like going to DMV. You take the test and you pass. So assignment number 7, same thing. So everyone should get 100%. Project, which is 40%, is more fun than a project. So, let me see. This is not the project that I wanted to assign. I think, okay, this time I changed the project. And I'll tell you what the project is gonna be, and I'm sure you'll be pretty excited. But here is a choice. And the reason I had to give this option, once again, because there are students who are not here. They are out of country. So I wanted to give them an option of doing the project alone if they want to. So I want to extend the same option to you. Say, I don't want to work with anyone. I am a lone ranger. I do stuff on my own. I'm so smart, nobody can work with me. That's totally fine. So then you can choose the project for one. And what is that project? The project is you will have to finish the course and get a nano degree in robotics engineer, deep learning, machine learning, AI, flying car engineer. So you don't have to do the final project, which is actually super interesting, and I'll tell you. But if you say, hey, I don't want to do anything with the hands, that is somebody else's job. I'm just going to write cool software. That is fine. But then take one of these as the final project. Everyone understood this? Again, these courses are just like DMV style. I mean, you can take as many times as you want till you actually crack the course. So, but whatever you do is totally fine. So you have a choice. But if you say, hey, I want to work in a group of 3 or 4, this is not the right project. So I'll show you what project I want to assign, and I will upload that here. So this year, I want team of 4 students build 3 robots, and I will give you the kit. That kit is about $300. I'm gonna give you the kit. And the 3 robots that I want you to build are, first, I want you to build a self-balancing bike. And then program it, control it using Matlab. The second project is I want you to build a bot, which you will program on, it's a webcam control bot. You will actually program it on the computer, and that bot will go to a certain location and do a task. And the third project is I want you to build a drawing robot. And some of you may say, oh, that is too much. No, I will give you step-by-step instructions, like take this, do that, all that type of stuff. So there are going to be step-by-step instructions, but every assignment will have a twist in the end. So for an example, after I will show you, or I will give you step-by-step instructions to build a self-balancing bike that can only do straight line. So the self-balancing bike will balance itself and just follow a straight path. But I'm going to ask you to change it so that it can do a circular path. Okay, so it's all there. For the second, for a lift bot, I will give you step-by-step instructions, and I'll show you those instructions. They are actually super step-by-step. Grab this, take this. Then it actually you'll program the trajectory. That bot will go to a certain trajectory and do a certain task. That project, I will give you all the building blocks, all the code. But then at the end, I would ask you to add obstacle avoidance. Last part is drawing. So basically you draw and the robot draws. What I want you to do is, I want you, and basically I will give you I'll show you how those instructions are going to be, and they are going to be super simple. once you build that robot, I want you not to make just one circle or one triangle, but I want you to create your name. How you make your name, it's up to you. But I mean, you'll see, it's not that easy. But once you understand that, believe you me, that you will understand the state flow, you will understand the controls, you will understand how to program a microcontroller using Matlab, how to modify the code, how to do the embedded system programming. So there will be a lot of fun. So it will be 4 students working together. Okay. Now I want to, and I'm super excited about the project because I did those projects and I learned a lot. Honestly, I learned a lot. Okay, so what I want to do is, this is the kit I'm gonna give you. And when I say I'm gonna give you, I already bought those kits for $10,000. Yeah, I didn't pay for it though. So Arduino Matlab Robotics Kit. Yeah, this is called Arduino Engineering Kit. This is the kit I got. This kit will allow you to build a self-balancing motorcycle, a rover, and how do I get rid of this? Help us improve this page. Don't stop showing annoying messages. Okay, so it includes everything, and there is a video on how to use it. But what I want to do is, actually, I want to show you, and this integrates very well with the Matlab that we have on campus. So you can download. This is the kit. So with tax and shipping, it comes to be around 300 bucks. So the kit, I already have the kits. So depending upon how soon you form a group of 4, you can come to my office. Actually, first thing first. First, you have to decide whether you want to work on this project or you want to do your independent project just on your own. If you decide to work on this project, you have to find 3 more partners. These kits are so expensive that I cannot give 1 kit to 1 student. So 4 students, I will give 1 kit. Only requirement is, at the end of the semester, you will give back the kit the way I gave it to you. Because otherwise, it's not possible for me to purchase the kits again and again and again and again every time I teach robotics 1. So then what I want you to do is, and these instructions are so nice. Let me show you. Yeah, here, preview the content. If you look at this content, it will take you to this engineering kit. Instructions are in English and Spanish. So it will actually show you how to assemble. Not only that, it will give you the dynamics background, how to derive the differential equations of motion, starting from first principles. It will also give you the background on how to find out the properties of different materials or for different components. Then at the end, once the theory is over, and please understand, I'm going to discuss all these equations and everything as part of our course. So there will be a time, then we will derive these equations. They are using Newton's law. We will derive those using Lagrangian dynamics, but that will come after the mid-semester. Then here is how you implement the controller inside Matlab. Then how you program the Simulink to run the differential equations. And then how do you actually create this whole block? Then how do you change these parameters? Look at the performance. How do you check the simulation? At the end, then how do you migrate this onto the state flow? This is very important. And then you go down and then it shows how to build it. So here you can see how the PIDs are tuned and all that stuff. This is super practical. So you will see that for certain gains, the system will not work. For certain gains, the system would work, so on and so forth. And then it will actually show you how to build it. And you can actually use the Simscape to create a model and integrate that with the Simscape model. And then at the end, you can actually create a nice figure like this. The step files are provided, so you don't have to create this. The idea is how do you import a CAD geometry? I can't emphasize this enough. In industry, you are not going to construct something by hand. There will be a CAD model for a robot. You have to import that CAD model, assign the mass and inertia properties, and implement the controller, and then do the dynamic simulation and so on. So, and if you go through all this, it will also tell you about the I2C interconnect to interconnect connections and everything. And then at the end, what you do is you actually build this and then have it run. So you can actually run this. You can also add Wi-Fi to it. System is the hardware is capable. So, but I did not do Wi-Fi. But if you guys are interested, you can actually add these subcomponents to it. So we'll see. There is a lot of stuff. Similarly, there is a hands-on step-by-step guideline to build the second robot and the third robot. So I would strongly encourage you to think about doing something like this, hands-on. Then the next question is, where would you test it? So once you build it, you can't, I mean, for us, if you want that bike to make a circle, you can't make it a circle in a very short, because it does not have enough cornering radius. It's not a car. So you would want to make a large radius circle. And this is the place where you can actually fly your drones indoors. I'm the director of the drone studio. So, and I would actually reserve some time, maybe Friday for 4 hours or Thursday, Friday, 4 hours, wherein you can actually visit the drone studio and actually learn how to use the motion capture equipment. So this drone studio used to be a indoor basketball court. We took it over, we converted that into a huge motion capture facility, 10,000 square foot motion capture facility. So you can fly your drones, you can have your balancing bike to a big circle inside this facility that is safe, air conditioned, so you don't have to sweat, and basically just it's free from distraction. So this is where you will actually test your robots. So the first two robots, you need some space for testing. There are additional things that you can do, and I'm not gonna recommend that to undergraduate students, but for grad students, if you want to integrate the motion capture with the motion of the robot, you can do that. So for an example, the robot would have motion capture dots, and the OptiTrack system can actually do the triangulation and tell you where the robot is. So you can perform a sort of a closed loop interaction between, or if you want to do swarms, like two robots coming together and performing something called as a collaborative task. A simple example is you have this bot, but the weight is beyond the capacity of each bot. So these two bots come together, they lift, and then they work as a team. So that is called as swarming. Something like that is also possible. So I would encourage you to look at all this great facility we have. So by today, please decide whether you want to work on a project on your own. If not, form a team of 4 students. And then on Thursday, after the class, you can come to my office and check out the kit. So any question? Yeah.
If you wanted to do the nano degree programs outside the project scope outside of this course, are they free for ASU students?
Nano degree? Oh, nano degree, that what I gave you. I could do those for free. So basically, but apparently those things change. But if so, yeah, you can do it, then register, get the degree, and cancel the subscription. Any other? Yeah.
Where's the drums being?
Tempe. Bulldog Hall. You know where the Bulldog Hall is? It's it's just, I think it's on the forest. So just check Bulldog Hall.
Right next to the bookstore.
Books, yeah. Okay. Now let me answer this question. Where is all the hint material? So if you go to modules, every lecture that I showed in the schedule has a PowerPoint slide and a video lecture associated with it. It's already posted. So all the lectures are already posted. So you can see now I added my lectures from last year because, as I said, I got carried away a couple of times and I actually worked out the entire assignment problem in class. And again, I wrote the Matlab scripts. They are also here. So if you look at the notes and all that stuff, pretty much they include the solution, maybe full solution or partial solution, or to the point that you are able to get the solution done. So in last year's live lecture videos. And then just like that, I will upload the slides and the video lectures for fall 22 here, because sometimes I may not cover the exact same problems. I don't want to repeat the same material. So usually I choose different problems. Sometimes I use different techniques. And you'll realize some of those techniques that I discuss in class, you won't find those in the textbooks. So I learned those techniques as I was teaching this class again and again and again and again. Then I realized, hey, why not to try something like this? Why to use this parameter? Why not to solve this particular problem using some different techniques? So I personally always learn some new things every time I teach this class. So whatever I learned in last year or year before that, I will try to incorporate in my lessons for fall 22. As you can see, there are no quizzes, there are only assignments, and there is a project. Assignments are expected to be, you should be working alone. So because if you don't work alone, please understand, plagiarism is viewed very seriously, and I don't grade the assignments. What I'm gonna do is I'm gonna I worked out the solution. I'm gonna give that solution to grader, and that grader is going to look at the solution. And the grader is someone who took robotics class earlier, and I can tell you, they are very smart in seeing the pattern. So if they see that your assignment is copied, values are copied, code is copied, they won't even report to me. They will directly report to the program chair. So I won't be able to help you. Okay. So please don't copy. There is no reason to copy because, to be honest with you, well, going into the course that you are going to get 40 points from the project, 10 points from the first assignment, 10 points from the second assignment. So basically you have 60% of the grade already determined. So you have to just work hard on remaining 40%. I think all of us can do that. Yeah.
So those nano degrees are the individual project.
Yes, individual.
Right.
The reason I tell you nano degrees, there are two ways to do this. Sometimes their policies change. Sometimes they don't give you certificate, but you can still audit the course. So if you audit the course, if you just upload your assignments, that's cool. But otherwise, what I would recommend, complete those nano degrees, get the certificate, upload that on your LinkedIn, because I know for a fact that my students have gotten jobs because number of courses that they have done on LinkedIn. So but basically it actually makes your profile, the LinkedIn profile, stand up. And you can mention that in your resume, like, hey, I had nano degree in driverless cars. So definitely you are much better than the person who has just only taken robotics one. Yeah.
In the kit you're gonna get, we can make the 3 robots simultaneously, or like there are not enough parts, you'll have to make one, then dismantle it and make the other one.
Yes, you have to make one. You can't go parallel.
Okay, so it's gonna be this.
And please don't do parallel or don't change the sequence, because there are some things, even though you may say that, hey, this is simple, you will need to learn, especially the control parts, tuning the controller. So I'll tell you, that kit is designed by robotics instructors with a lot of experience. So that kit is like a gradual progression. So once I give you the kit, once you register at Arduino website, it will give you a nice 8-chapter lab manual. First 4 chapters are like preparatory, like state flow, how to do it. How do you program a microcontroller using Matlab? Because let me tell you, when you go to industry, very rarely you will be asked to write the whole code by yourself. You will be given some code that you have to debug, improve, modify, or if you are like me, you will write the code, simulate it inside the Matlab, and then just convert that code into a hex file and flash it on the firmware. So, and again, it depends upon what you want to do. If you're a systems person or a robotics person, if you're not a hardcore embedded systems guy, most likely you will not write the code. So this is something that I would strongly recommend you to learn. Like, how do you write the code? How do you program inside the Simulink? How do you simulate? How do you do hardware in the loop? How do you do software in the loop? And finally, flash that code out onto a microcontroller. That is a very, very important skill. I would strongly encourage you to learn that. Yeah.
So by when I will decide that I want to go for the individual thing or the team.
By Thursday, because by Thursday the groups will be formed, and then you will come and pick up your kits. So by Thursday, I would strongly encourage you to decide what you want to do. Let me say this way, there are enough number of kits available to support our students.
Where on Canvas can we find the different options for the projects?
Why do you have to go on Canvas? Oh, in the last, okay. You mean just to see what
Yeah,
project?
what projects are available?
Okay, so actually, this morning, I changed that, but I think I forgot to save. So let me see. If you go on to assignments, if you go on to project, yeah, so don't ignore this project one, okay?
Okay.
I will upload the new project here by tonight, but the self-directed study is over here.
Okay.
But please note, this is an individual project. Okay. So if some of you are really passionate about, hey, I want to go work for Waymo, or I want to go work for Uber, or I want to do something, then probably this driverless car course is better for you. If you are like, hey, I want to be master of TensorFlow, yeah, then do TensorFlow. I want to be expert in reinforcement learning, yeah, sure, reinforcement learning. So if you want to become self-driving, if you want to become a flight engineer or a UAV engineer, then you can do this. So that's why I wanted to make this course as flexible as possible. Yeah, question? Yes.
Yeah, so, this first 6 are paid one and other are free, right? You have mentioned the free.
I think you can register and you can take. I to be honest with you, when I did those courses, I pretty much did the course for free, and the courses which were not free, I registered, finished those in 7 or 8 days, and then cancelled.
Currently, there is no option like that. I think I'm doing the self-driving car course.
No, you can cancel your subscription in first 30 days or something. Yeah, look at it.
But no, sir, I think they cancel the certificate if you don't make a single payment.
No.
They can withdraw the certificate, but then you can take a picture of the certificate. It's just like get stuff from Amazon, use it and return it, right? What project?
The projects are getting free.
The 3 projects.
Oh, you have to. This is part of the coursework.
Right, but it's not-
No. I give you the kits. You can do wherever you want. If you want a place to do the project, there is a place on Poly campus where you can come and do the projects. If you live on Tempe, I'm sure you can find places on Tempe. So, yeah.
If we do the project and then we do one of those on the side, would that be like an honors contract? Would that count? For the requirement?
Honors contract is something else that we'll talk about. But if somebody wants to do honors contract, yes, then you do the project, the group project,
Yeah.
and then you do the individual one, and that would be an honors contract. So if you go to your honors contract page, just select a course and then say you will do this course as part of honors contract.
How long is it now?
How long is a nano degree? It will take nanoseconds. It totally depends upon how much time you have, how much committed you are, and how much excited you are to learn. So basically I wanted to save money. So I registered, I did it, and then I canceled my subscription, but save the certificate. So it's totally depends upon, and you can preview the content of the nano degree before you choose. But again, there was a student who said, I already did this nano degree. Can I submit it? I said, you can, but that is not the purpose. If you have finished one nano degree, might as well use this time to do the project or do some other nano degree. Because that, so let me tell you, if you want to be a robotics engineer, Robotics 1 is the only class that is offered for our robotics concentration student, which will cover this stuff. And robotics, if you are doing your masters, Robotics 1 is the core class that you have to take before you continue in your degree. MS in robotics and autonomous systems. So that's why I think this course is very important, and it will give you a lot of practical tools that will help you find jobs. Yeah. Of course, there is no free lunch. There are quizzes, but the solutions are available on checks.com. But they could be wrong because they keep on changing the quizzes. Any other questions?
So it's 3 robots per team, right?
Yeah. 3 robots per team. Anything else? Everyone, okay. Now, yeah. No, I'm not gonna decide. You can form the groups, 4 students working in one group. 4. I cannot give a $300 kit just to 2 students, right? We have to have 4 students. What? The grading?
No, asking, there will be 4 teams, no? So you'll be giving each pick to each one. And then you said there are other parties like individual people.
Okay, so let me clarify. What you will do is, first you will decide whether you want to do an individual project or a group project. Let's assume that you want to do a group project. Group project is nothing but building 3 robots, not simultaneously, but serially. The team of 4 will go through that manual step by step, which you will get once you enroll and you get once you log into the website. The first part is building a balancing bike. We'll finish that first. Demonstrate it to the grader. Then you will have to dismantle it, build the second robot. Demonstrate that to the grader. Dismantle it, and then you have to build the third robot. Build it, show it to the grader, dismantle it, and put everything back in the kit. And what you do is, every student, even though you work in the group, will submit an independent report for the project. It could be the same report, but every student has to submit it. Everyone understood this?
So we have to submit all 3 video files of our recordings together, right?
You can, actually you won't be able to, you can do it together or you can do it separately.
Okay.
I would recommend you doing it separately. Once you're done, upload it. Once you're done, upload it. Something like that.
I mean, you just explained the group project thing. You didn't explain the individual.
Individual project is complete the whole nano degree. Take that certificate, upload the certificate. If you don't pay and if you just want to do a course, then you can upload all the course material. I have the solutions worked out. Upload all your solutions onto Canvas. But you have to score more than 90%. And that you can do because once you basically it will auto grade and everything. You can't just do half 50% and expect complete full grade. So it's the, again I said it's pass or fail. It's a successful completion of the course with more than 90%. So you will get 40%. Fail means unsuccessful completion or grade less than 90%. No negotiations. Okay, I'm telling you in advance. Oh, I got 25%, so I could get 10. No. Oh, I've been there. Okay, so that's why it's all written there. Okay. Online students. Any questions from online students? If you have not done so, please install Matlab because Matlab is our tool of choice. But understand that all the assignments that we talked about can be done using Python. So if you want to do it using Python, that is totally fine. But then you need to be really good because I don't have the Python solutions, or if you get stuck, I won't be able to help you. So that's the only thing. Okay. Does anyone have any other questions? Yeah.
Can student do both, group project as well? And what is honors contract?
Honors contract is for undergraduate students. I do not so if you want to do, I mean, why to do unnecessary work? Just do one of. I mean, if you want to do all, then why not one? Why not 8 of those? I'm totally okay with it. So then you'll say, why not A? Why don't I get A plus since I did everything? So there is, please understand, you have limited amount of time, and I understand that you're like, hey, I want to. Right now, the semester is just beginning. Okay? All that steam will go out in 2 weeks. Okay, so I mean, I so my recommendation to you would be just just do how much is required, what is needed. If you want to learn these courses, you are gonna have access to this Canvas website uh, throughout your time at ASU. You can still go back, review the material. But as a matter of fact, I just want to tell you, if you want to increase the job prospects, the more courses you do, the higher salary you will get. I give an example. My student, Surya, he came here, finished his master's in flat 10 months, not even 12 months, 10 months. And now he just got hired by Raven. You know where Raven is? How much salary he's making? He's making twice than what I'm making. So that's great. So do as many courses as you can. Do make your LinkedIn profile as jazzy as you can, and then keep on pushing some updates on the LinkedIn. Also, quickly this Friday, we have a graduate student welcome. So please attend the graduate student welcome, wherein I would actually talk about, I don't have time in this course to talk about what job market is going to look for, but this Friday, I will kind of tell you what would be the job outlook when you graduate with a master's or with even your bachelor's. There are lots and lot of courses for robotics and autonomous systems program. We worked very hard to put those courses together. Also, I just want to tell you that we are going to start some more initiatives. So we are going to have a monthly sort of a seminar or some type of a get together, wherein I'm going to invite the professors, especially the professors who are looking for graduate students and who have funding. That is very important. Yeah, I want students. I don't have funding. You don't get a spot. So, and then I'm gonna invite folks, industry folks from Raven. I'm gonna invite folks from Aerospec, where our students got placed. I would also invite my students who I graduated, now currently working in Facebook, Google. They will give their talk over Zoom. They will share their experiences, like what they have done, what did they do at ASU, how was the interview experience, how to get a job at Google, and etc. at Ford. So you will get first-hand perspective of what it is to go through this curriculum and go out there and gain the important professional skills that you need to be successful professionally. And then I'm going to invite, as I said, quite a few professors. If they are located on Poly campus, they will come and deliver their talk in person. But there are some good professors at Tempe, which I'm trying to get to talk. They may actually give talk via Zoom. So, and again, if you have not done so, please join our LinkedIn profile, because that is where I post new jobs, new internships. I used to do it in my robotics one class on Canvas, but then students started saying that, hey, we don't have access to your Canvas. And that's true. So nowadays, if I hear about a job opportunity, or if my students contact me, say I'm looking for 3 or 4 more interns, students, or I'm looking to hire some engineers, I just announce that on the LinkedIn. So if you have not done so, please join my LinkedIn. Yeah.
That is on 26.
No. 26 is just me.
So where's the link for the?
Oh, your advisor should email. Oh, that is actually in person. No Zoom link. I'm just kidding. No, sorry. It's a Zoom. Yeah, because there are just way too many students that can be accommodated. So yeah, there is a Zoom link. I think your advisor should have notified you, but if not, I would announce that on to LinkedIn. Oh, old students can come too.
The advisor won't mail the old.
Yeah, that's why I will mail everything onto my LinkedIn. So you can new, old, prospective, current, future, everyone is welcome. Okay. And what I want to do is, since I don't have enough time to cover the material that I wanted to cover, I just want to talk about my lab. So currently I'm leading Robotics and Dynamical Systems lab, RADS lab. So my research, let me show you quickly about the lab projects. So when I started working on this program, I was always interested in autonomous systems. So I built something called as an inertial navigation system. This is currently used in Bell 609 tilt rotor aircraft, the aircraft that takes off as a helicopter and flies as a plane. Then we added that to something called as the Cervical night vision goggle. So the idea is you have this night vision goggle, and you have the soldiers, SOCOM guys, have this machine gun. Earlier problem was if they want to shoot a target, they have to take the night vision off because it's a whole big thing. Use the rifle or use the machine gun to target and then basically shoot. But with this, you have an IMU on the top, you have an IMU on the rifle. So IMU means 3-axis accelerometer, gyros, and mag. And basically, you can shoot actually Terminator style. I don't know if you have seen Terminator. Like, oh, there. So you don't have to actually aim. You can aim in your night vision goggle and basically shoot from your AK-47 or whatever gun they are using. So I have been always interested to work on the DoD programs because I think our war fighters need help. They need technology to keep us safe from the bad guys. So then I worked on this body orientation sensor system, which is basically, again, the same IMUs incorporated in the body. So you see what is the relative motion after impact. This is the project that got us a Best Buy commercial. I don't know if you have seen this, but if you want to see it, it's on the website. So we built a wearable robot that would allow wearer to climb vertical walls. We developed this, give it to the military. We built a wearable air conditioner. So this is actually an air conditioner, the same air conditioner that is in the car or at your house, but it's so small that you can carry it. You can actually wear it. Then we built a jetpack, not for flying, but for running. So basically you have a jetpack. And basically what you do is you wear this jetpack, it gives you a thrust. So basically it gives you a push as you are running. So one of my students, basically this dude, he actually wore that jetpack. Instead of running, he used a skateboard. So he had a jetpack, skateboard, and he was riding his skateboard on this innovation. At that time, it was called Tillman Avenue. And then he got a ticket. Why? Because the speed limit was 15 and he was going at 25. But then again, he cried, oh, I don't know. There is no speedometer on the jetpack. There is no speedometer on the skateboard. I didn't know this, that. And somehow he talked out of it, but he got a ticket. This is the, yeah. So always be careful with the graduate students. They try to always push the boundaries. So at least I'm glad he did not wear the jetpack and jumped off of the water tower. Hey, I'm flying. So then Pogo Suit, this is the Eddie's friend. So basically this is the jet Pogo Suit, wherein the mass oscillates up and down. and that inputs energy into the walking gait. These are the autonomous robots that we built: track, wheel, robot that will track, walker. Then hip exoskeleton, the robot that would assist walking. Then fingerprint with pulse oximeter. So basically, if there's a wounded soldier, you can't ask him what's your name, right? The person is wounded or unconscious. So basically, we have this system that actually has a biometric and it can monitor the vitals. So again, passive slope adapting ankle. This is again a passive robot. This robot can actually, you can use it for going up the slope. Then this is a new this is the program that we are currently working on, in-ear pulse oximeter sensor. The idea is the tactical fighters like F-16 or maybe MiG or Sukhoi, when they pull very high Gs, the blood flow to the brain drops down and the pilot becomes momentarily unconscious. That is called as gravity-induced loss of consciousness, or G-lock. Okay, so they wanted to monitor or sort of detect the onset of G-lock. Hey, G-lock is going to happen, so that the flight control system can take over. So we build this sensor that the pilot can wear in the ear. It measures the blood oxygen concentration. As soon as it drops down below 10%, by 10%, you know that the G-lock is going to happen. And at that time, basically, the flight control system can restrict the Gs that the pilot is pulling, or basically the supplemental oxygen can flow, or what they use is they use anti-G suits. Those are like balloon actuators. They inflate and they pump the blood. So then how many of you have seen the movie Iron Man? So believe it or not, basically we were building an actual Iron Man. So, but the problem was that Iron Man robot was so heavy that you cannot move it. So we were tasked to build this base layer, which is the suit, basically a body suit or base layer that is instrumented. There are IMUs and lots of other sensors. And what we do is we capture all the kinematics data from this suit and then interpret that and then see what is the intent of the user. So if that person wants to walk, wants to raise hands, sit down, jump, etc., etc. So the robot can do it before the person actually starts moving his hand. Otherwise, person wants to move the hand, but robot is so heavy that he cannot move. So basically, you can look it up. It's called Talos. So then we built cervical spine sensor system, which is something interesting. You'll hear about this a lot, which is called as the digital twin, which means you have a mathematical neuromuscular model. You have the person who is instrumented or wearing sensors. The data from the sensor is continuously fed into that mathematical model. So that mathematical model can predict what that person is capable of doing, what is he doing, what he did, etc., etc. So this is one important area where there will be lots of jobs. Digital twins. So Google it. So second important area where the jobs are going to be next year is in cyber secured robotics. So look it up, because right now people are so scared about these autonomous cars that they don't want these autonomous cars to stop on their own, because that happens, it could lead to a big accident, loss of lives. So these robotics platform, even agricultural robots, so it's just like internet. We build the internet and then realize that internet is not secure. So that's why now there is this cyber secured robotics. There is another thing like hardware-based cyber security, which means you are developing the hardware that cannot be tampered with. So how do you design the robots that cannot be tampered by using hardware or software? Okay, this is something that we built. Believe it or not, we built an X-ray vision system. What it means is you can see behind the wall. So you have this system wherein it has a Doppler radars. You place that on one side of the wall, and there may not be any. So it's completely like made up with concrete, stucco, and what it will do is it will get the Doppler signatures, and then you can predict what is going on behind the wall. I don't have this system in the lab because after we developed it, our DoD sponsorer said we want it, and they took everything. So, and there are other programs that I worked on. So, lot of crazy stuff. And these are the only programs that are available in public domain. I have also worked on a lot of programs that are classified and ITAR, so I cannot talk about those. But trust me, I learned a lot of stuff. And these are all the videos of the different technologies. So I think there is also a technology, I think, yeah, these are different. I don't know behind the wall thing is here, but yeah, when you get a chance, I would encourage you to visit our website. And this is something interesting that I want to talk about. So my student here, Sandesh, Dr. Bhatt, is wearing the sensors, and these sensors will track anyone anywhere without GPS. And I want you to think about it, that you get GPS grade accuracy in GPS denied environment, which means if you have a firefighter, first responder going into a building, you know where that person is all the time. So as you can see, that person is walking. This is the first system in the entire world who can actually compensate for the magnetic anomalies. You can see his avatar is tracking whether the magnetic field is changing, or even though the surrounding is changing, you can see the center of motion is pretty accurate. So you can get centimeter grade accuracy just based on IMU sensors. Again, we developed this technology and we passed it on to our government sponsors. With that, I'm gonna stop here, and I would be happy to answer